You are in New York City with your friend to see the new World Trade Center and the Statue of Liberty. Your friend says, "I don't know the height of the World Trade Center or of the Statue of Liberty. But, I bet you $10 that the average height of the two is greater than the square root of the product of the two heights." Should you take up the bet? You should not take up the bet even though you trust your friend to not know the heights of the two structures. Let's see why. Let's define a couple of terms first. The average of two non-negative quantities, L and W, we will call as arithmetic mean, AM. The square root of two non-negative quantities, L and W, we will call as geometric mean, GM. Imagine we form a rectangle, with one side W corresponding to the height of the World Trade Center, and another side L corresponding to the height of the Statue of Liberty. The area of this rectangle is W multiplied by L, which is the geometric mean squared. Let's make a copy of this rectangle, color it yellow, and place it as shown. The two rectangles together form a side of length L plus W, or 2 times the arithmetic mean, AM. Let's make 2 more copies of the rectangle, in red and green, and place them as shown. The red, blue, green and yellow rectangles together have area 4 times LW, or 4 times the geometric mean squared. The outer edges of the 4 rectangles form a square of length, L plus W, or 2 times the AM. Area of square must be 4 times AM squared. There's a gap in the middle of the square that's not covered by the rectangles. So the square has area larger than the area of the 4 rectangles. So 4 times the square of the arithmetic mean is greater than 4 times the square of the geometric mean. Taking square roots on both sides, we get arithmetic mean is greater than or equal to geometric mean. In our illustration, geometric mean was strictly less than arithmetic mean. Shortly we will see in an animation that at most, geometric mean can equal arithmetic mean. As the animation begins, W is much larger than L. As the animation proceeds, W decreases by some quantity and L increases by same quantity, and we stop when W equals L. Only when L equaled W and formed a square, we saw no gap at the center of the larger, L plus W, square. Next, let's start with L equals W, so initially there's no gap and arithmetic mean equals geometric mean. Watch what happens to the gap as W increases and L decreases by same amount. Initially, there was no gap at the center, and arithmetic mean equaled geometric mean. As W increased by some quantity and L decreased by the same quantity, the gap kept increasing and arithmetic mean gets strictly greater than geometric mean. In summary, arithmetic mean is greater than or equal to geometric mean, remember the gap. Arithmetic mean equals geometric mean only when both numbers are same. Only if L equals W do we have a square and no gap at the center.